All right, AGS1, welcome back. Today we are doing 3.4, which is the water park. Some things we're going to put in the toolbox today. Let's see, we're going to talk about linear equations. Don't like that highlighter. Let's try orange. We're going to talk about linear equations. We're going to talk about slope, slope-intercept form of those linear equations. Those are our main tools. So, the essential question of the day, what comparisons can we make between two similar functions? Here's the main problem we're working with today. There's Allie, which we're going to call A of X, and Dane, who we're going to call D of X. Both these people work at a water park, and they have these giant pools that they have to drain at the end of the day. Now, Dane's pool, all the info that we're given is that it drains at 1,000 gallons per minute and takes 24 minutes to drain. Allie's pool holds 28,000 gallons and takes 20 minutes to drain. So we don't know her rate, but we do know how much her pool, total her pool holds, as opposed to Dane, where we know his rate, but we don't really know right off the bat how much his pool holds, although you can figure it out pretty quick. So, first thing we're going to look at is just Dane's pool. So, if I use my highlighter, D of X, that's this line right here. So in the book or the curriculum or in the Go Formative, they gave you this graph so you can kind of see what these two pool situations are like. First thing I want to do is come up with a y equals mx plus b, a slope-intercept form for Dane. Now, remember that m is the slope. There's a couple ways you can think of this. Slope is the constant rate of change, which we already know that his pool's draining at 1,000 gallons per minute. If you look at his sort of slope triangle from this point to the next point, it goes down 24,000 and goes over 24. So this is down 24K and then to the right 24. So if you take your slope is rise over run, there was a negative rise, so that's negative 24,000 over 24, which equals negative 1,000. But we already sort of knew this back up here, that his pool drains at 1,000 gallons per minute. That is the slope. It's the constant rate of change. So we know that his equation so far would be y equals negative 1,000x plus b. Now, the b value, just a reminder that this is your y-intercept. So, if we look at the graph right here, his pool line is crossing at 24,000. So, we can actually write the full equation that this is y equals negative 1,000x plus 24,000. Okay, so let's put a box around that because that's an important equation that we're going to use in this lesson. Couple things about that. Let's go ahead and state the domain and range. Now, you guys, the domain is all the possible inputs for the equation, which is also all the x values that can go into it. Because time is in minutes, like you can start at 0 minutes for Dane's pool and go all the way up to 24. But then after 24, the problem sort of ends because his pool has been drained. So in interval notation, we would say this includes 0, because you can have 0 minutes in the problem, and goes all the way up to 24 minutes. But it's going to stop there because it wouldn't make sense to talk about 25 or 26 minutes because nothing's changing about the pool. It's already fully drained. The range is all of the y values or the outputs that can happen for this problem. So if you look, it starts at 0 and goes all the way up to and stops at 24,000. So the range is going to include 0 and go all the way up to 24,000 and include that number as well. So this was all for Dane's pool. Let's take a look at Allie's pool. I want to come up with a y equals mx plus b for Allie's pool, which is a of x right here. Now, first thing I notice about this is that I can see that it crosses at 28,000. But the one thing I don't know is the slope. So if I want to write a y equals mx plus b, I can already see that this, the y-intercept, is 28,000, but the slope is the problem. We were kind of given the slope of Dane's pool, but Allie's pool, I think we're going to have to resort to this definition for slope. That m is, how do we know how to put this? Rise over run. It's change in y over change in x. Or an alternate formula is y2 minus y1 over x2 minus x1. I'm going to focus on just the change in y over the change in x. So if we take a highlighter and look at how far from this point to this point, what changes in terms of the y and what changes in terms of the x. So first you look at how far up or down it goes. From 28,000 down to 0, that's 28,000, and then it's going to go over 20. So the slope for her equation is negative 28,000 over 20. But this is not a fully reduced fraction. So at this point, you could grab a calculator if you want, or there's some like reducing tricks you could do. But I'm fine if we just calculate it. 28,000 divided by 20 is negative 1,400. Oh, duh, because 2 goes into 28 14 times. So the slope is negative 1,400x. Or just negative 1,400. This means that her pool is losing 1,400 gallons per minute. As opposed to Dane's pool, who's losing, what, 1,000 gallons per minute? So her y equals mx plus b is negative 1,400, that's the slope and the rate, plus, I did not leave myself enough room, let's just get rid of that. It's going to be y equals negative 1,400x plus her y-intercept, which is 28,000. Now the question that we have to answer is, after how many minutes will they be at the same water level, the two pools? You guys, what we're going to try to find is this point right here, because this is the spot where they have equal water after equal time. Because they would both share the same, same water level over here and the same amount of time that's passed. There's ways you can do this algebraically. You could set the two equations equal to each other and try to solve with algebra. But since we have the graph right in front of us, I think we should just kind of estimate what the x value is for this point. Now, I drew a line down, and it looks like it's about 10. But I'm not really sure if it's exactly 10. If it's like, 10.2 or 10.5 or something like that, based off how directly I put my line. So I think it's 10. But if this were like a test or a quiz, I'd be really unsure of myself. So I'm going to teach you guys a trick to be able to figure out whether or not this is the right answer. So for Dane's pool, his equation was negative 1,000 x plus, what was it? 24K? And for Allie, her equation was y equals negative 1,400 x plus 28K. So, I shouldn't use y's with those. I forgot we were doing a of x and d of x. So d of x is equal to that, and a of x is equal to that. What I want to do is check to see if I put 10 in for both of these, if we get the same pool level. So I'm going to check D of 10. And I'm going to check A of 10. So let's see. 10 times negative 1,000 is negative 10,000 plus 24,000. If you take 10,000 off of 24,000, you get 14,000 gallons. Over here, we get negative 14,000 gallons plus the original 28K. So 28,000 take away 14,000. This one also equals 14,000 gallons. So algebraically, I've shown that because these two match, horrible highlighter, that yes, that after 10 minutes, they both have the same amount of water. So after 10 minutes, they both have 14,000 gallons. Which, if I look up on the graph, like, does this look like it's about 14,000 right here? Let me see, that's 12,000, that's 20K, so that means that there's 8 in between, so this would be 16. Yeah, I'd say that's about 14, exactly, like in between 16 and 12 is 14. Cool, just another way to check ourselves. Okay, you guys.